Magnitude of a vector. All right, the magnitude of a vector is its length. That's all it is. We use a special notation in math to denote magnitude. It's kind of like the absolute value signs, like, you would take like an absolute value of x. But for vectors, magnitude, we do two lines. It typically looks like this if you're like handwriting it. You try to make those big bars stand out so that they don't look like ones. But that means the length of the vector. And it's real simple geometry here. If you look at x and you look at the x and y components, x component, y component, v is the hypotenuse of that triangle. And since x and y get squared in here, it doesn't matter if x and y are negative, and length is a positive number, so this works out great. It's literally just a squared plus b squared equals c squared. There you are. There's the formula for magnitude. So we will do some examples here. We have u equals 8 comma 8 comma 12, w equals negative 3 4. Find the following. So magnitude of u, this is going to be equal, magnitude of u is equal to the square root of x squared plus y squared. For u, the x component is 8, so 8 squared. Y component is 12, 12 squared. That's going to be the square root of 208. 14.42. I didn't say round to the nearest anything, but say, put it in here, round to 2 decimals. (14.42). That's the length of that vector. For the magnitude of vector v, or w, again, square root of x squared plus y squared. X is negative 3, so negative 3 squared. Put parentheses. If you don't put parentheses, things will go wrong. Plus 4 squared. You don't need to do it on positive numbers, just negative numbers. And this is equal to the square root of 25, which is just 5. The magnitude of 3w. So first we need to find 3w, then we can find its magnitude. So 3 times w is negative 3 comma 4. Distributing that 3, we get negative 9, 12. So I just distributed him. So the vector 3w is equal to negative 9, 12. I'm going to use that when I find its magnitude. So we have negative 9 squared, parentheses, plus 12 squared. This becomes the square root of 225, which is 15. I want you to notice something here, something fun, something exciting. The magnitude of regular w was 5, and the magnitude of 3w was 3 times 5, 15, right? It was 3 times the magnitude of w. It's exactly what you hope would happen. 3w has 3 times the magnitude of w. All right, last thing is comparing these two here. Magnitude of u plus the magnitude of w. How does that relate to the magnitude of the vector u plus w? So what we're going to do first is the magnitude of u plus the magnitude of w. So we already did magnitude of u. That was the square root of 208. We rounded it to 14.42. And then this magnitude of w was 5. So adding those two together, we get 19.42. So the magnitude of two vectors, you have a vector u, you have a vector w. The question really is these lengths. If I could take this length here and put it onto here, how much would these two lengths together be? The question is their individual lengths added together going to be greater or smaller than this vector here, which would be the vector u plus w? We'll find out. So u plus w we have vector u, which is 8, comma 12 plus -3, comma 4. This will be 8 plus -3, 12 plus 4. So 5, comma 16. Now I'm taking the magnitude of that vector. So the magnitude of u plus w, that's going to be the square root of 5 squared plus 16 squared, the square root of 281, and that comes out to 16.676. And what I want to point out here, boop, boop, right? The magnitude of these two added together is longer than the magnitude of the sum of the two vectors. This is actually the triangle inequality. The magnitude of u plus the magnitude of w is going to be greater than or equal to the magnitude of u plus w. Is called the triangle inequality. Fun, exciting stuff there. But anyway, they're not the same number is important. These things are not the same. Adding the vectors together, then taking the magnitude is a different number than when you add the individual magnitudes together. All right, that's this for this video. One last video for this section, and I'll see you then. Bye.